Hi everyone, welcome back to our YouTube channel Sid Education. In our today's video, we are going to drive time complexity of quicksort in worst case scenario. In our previous video, we have already discussed about the best case and the average case, and this occurs when the pivot element divides the array exactly into two equal halves, or here into two parts which may not be equal. So and we have discussed that it was n log n. We have derived this result in our previous video. So let's talk about the worst case scenario. When do you think this worst case will happen in terms of quicksort? So worst case happens when we select largest or smallest element as pivot element. Okay, for example, you have a sorted array. Okay, I'll give an example to you. So quick sort is what? Is based on divide and conquer. Divide and conquer approach means if you have a problem, this big problem, you can divide this and this, you tackle in small problems, and then you can achieve this big problem. Correct? That is what even the best case says, that if this is n, you divide n by 2, n by 2. Average says that it might not be n less than n by 2 and it will be more than n by 2, right? But in worst case, what happens, you see? For example, I have an array 4, 5, 4, 3, 2, 1. And I choose this 5 element, the first element as P1, that is the largest element. Now, its position according to quicksort will be here. So, again, 1, 2, 3, 4 element has to come. Basically, again, I need to apply quicksort on these 4 elements, right? So if my problem was of 5 elements, now again I have to apply quicksort on 4 elements. Now I'll choose this as my pivot, then I have to again apply for 3 elements. Are you getting it? So basically, if my okay, let me give you another example. If you choose the smallest element, what happens? For example, 1, 2, 3, and 4. Correct? So if you choose 1 as pivot element, so you won't so right position of pivot is this only. It's correct. So now you need to solve for these 3 elements. So basically, if I say you have n elements, so your left subarray will have 0 elements and your right subarray will have how many elements? N minus 1. Then in next pass again, your left subarray will have 0 elements and it will have n minus 2. Instead of dividing, you are decreasing by 1. So it will take a lot of time, right? It will take a lot of time. So like this, correct? So you can derive from this also that it is taking n minus 1, n minus 2, so on, so on. So it is nothing but the t of n time complexity will be 1 plus 2 plus so on, n minus 1 plus n minus 2 plus n, which is nothing but what? According to you, it is nothing but n into n minus 1 by 2, that is n square plus n by 2. So asymptotically, this is dominant function, so n square is the time complexity. Correct. Same case for this. Instead of your n, your left will have n minus 1, right will have 0. And here again, your left will have n minus 2, right will have 0. Like this it will go. Are you getting it? So this is the quickest way you can understand the time complexity of quicksort in worst case. But let's actually drive this, okay? So when I drive this, I consider that if n is equals to 1, it is already sorted. So t of n will be of 1. It will take a unit time for sorting because it's already sorted if one element is there, right? If not, if n is greater than 1, in that case, t of n will look like what? So if you see, every time you're dividing into one less element. If you have 10 elements, you need to take care of 9 elements in the next pass. Whereas in best case and average case, you are taking care of the n by 2 elements. So remember there we have written that T of n is equals to 2Tn by 2 plus n. This is for the number of comparison, minimum number of comparison. So what will change? This thing will change. See, we can write constant here, that won't make any difference to it, right? When we write 4n, asymptotically we take n only, right? When we write 8, 3, 38 n square, this 38 is a constant for us. I will asymptotically write n square, right? All this we have already seen in our previous videos, right? So what will be the term? Do you think Tn minus 1 plus n into some constant I'm just writing for your sake, right? Because in every iteration I am just reducing the size by 1, right? In the next iteration I will reduce it by, so instead, so I'll just write for your safety, T of n becomes n minus 1. So now instead of n you have n minus 1. So if you put here you will get what? I think n into constant. So if you put in n minus 1 instead of n, you will get n minus 1 plus n minus 1 into constant. So T of n minus 1 you will get from this, that is T n minus 2 plus n into constant minus constant. Okay. So if you put all this value here, you will get what? You will get T n minus 2 plus 2 into n into constant minus constant. Are you getting it? Because n constant was already there, n constant came here, and this minus constant is this. Now in next pass, can I write directly? So you will get n minus 3 into 3 into n into constant minus 2 constant minus constant. So you see a pattern. So can you write it for k term? So T of n will look like what? It will look like T n minus k. Okay, this 1, 2, 3, so on k. Now 1, 2, 3, so on what? K into n into constant. And if you see only 1, then 1, 2, then you will see 1, 2, 3 like this. So I'm writing minus k minus 1 into constant minus so on, so on, so on. It will keep going on till one more minus constant. Are you getting it? So now what we have to do? Let's assume. So let's assume that k is equals to n and put here. So what you get? T of n is equals to T of n minus k. If you put n, you get T of 0 plus k. Instead of k, if you put n, you get n into constant square, n into constant, so on, minus constant, not so on. So now this is nothing but 1, 2, 3, so on, k minus 1. So you will get what? My bad. So n into constant minus constant into n into n minus 1 by 2. Because if you put n instead of k, and it is following a pattern, right? Sum of unnatural numbers. So I have taken minus constant as common and I have put as to common term. So what you got? T0 is 0. There is nothing, correct? So you get n square. If you take constant and you remove constant, because, okay, let's do this. Constant, you get n square. So this is become 0, right? If you don't have any element, you don't need any time. N square minus n square, okay? And minus n into n minus 1 by 2. So if you write this constant, you get n square by 2, and because this is nothing but n square by 2 minus minus plus n by 2 plus n by 2. So asymptotically, if you have to get it, you will get this, and in that also remove 2, so you will get n square. Are you getting it? So this is constant, right? So this is like constant by 2 n square plus n by 2 constant. So asymptotically we just take the dominance factor. Therefore, for worst case scenario, what is the time complexity? O of n square. So for quick sort for best, average and worst, it is n log n. For average also it is n log n, but for worst case it is n square. This is the conclusion we have made. So if you like this video, please do like, share and subscribe. In our next video, we are going to talk about space complexity for quicksort. Thank you.